This is video 109. It's going to be about the action ADDL, which means add list, and MULL, which means multiply list. Here is an example of a routine that uses ADDL. The next routine, 110, uses multiply L. We're going to go execute the program and look at these routines. Here is routine 109. It's an example of ADDL where there's a vector, a scalar, and an A1 offset jump. These two vectors we see here are A1 when the instruction starts and A1 when it's over. This scalar is at A2. This scalar is added to each value and the result is put back into A1. So 3 and 1 is 4, 3 and 0 is 3, 3 and 2 is 5. What's unique about this instruction is that these values in A1 don't have to be contiguous. Normally, this would be offset 0, offset 1, offset 2. But we have an option here that these values could be offset, for example, 20 apart. So it would be A1 plus 0, but then A1 plus 20, and then A1 plus 40. Alright, that's ADDL, vector, scalar, A1 offset. Well, MULL, or multiply list, also has that type. Again, it's the same idea, but it's multiplication. So instead of it adding the 3 to each value that was in A1, it multiplies the 3. So it's 3 times 1 is 3, 3 times 0 is 0, 3 times 2 is 6. Again, the special thing about this is these values in A1 before and after could be offset apart by a number, and I keep giving the example of 20. This could be at offset 0, this 20, and this 40. Alright, we're going to go on to another type. Here's add list, where it's a vector, a scalar, and another vector. This vector is at A1, this scalar is at address A2, and this vector is at address A3. It's going to add the values in this vector to the 3 and put them here. So they're going from A3, adding the scalar, and going to A1. So 1 and 3 is 4, 0 and 3 is 3, 2 and 3 is 5. These vectors are all offset by 1. So this is offset A3 0, A3 1, A3 2, and this one is A1 0, A1 1, and A1 2. Alright, this also comes in the multiply. So here's multiply list, vector, scalar, vector. Same idea. This is at A1, this is at A2, this is at A3. This is A3 offset 0, offset 1, offset 2, and this is A1, offset 0, offset 1, offset 2, but this is multiplying, so it's 1 times 3 is 3, 0 times 3 is 0, 2 times 3 is 6. Alright, that's that type. Now we go on to another type. This is your add list, where it's a vector, and the A1 jump offset. So in this case, both of these are A1. This is A1 before the instruction's executed, and this is A1 afterwards. And this is at A2. A2 is going to be added to A1. So it adds the 10 to the 1, gets 11, 20 to 0 gets 20, and the 1 to 2 and gets 3. The difference here is that these values in A1 could be like my example always is, 20 apart. So this could be at offset 0, this one could be at offset 20, and this one could be at offset 40. Alright, that's ADDL of this type. Well, it comes in multiply also. Here's the same idea, multiplying. These both are A1, A1 before, A1 afterwards. This is at A2. Well, it's going to multiply 10 times 1, get 10. 20 times 0 is 0. 1 times 2 is 2. But this is also that special case where A1, these are both A1s, they could be a different offset apart. And that value would be here in the A1 offset jump. Alright, now we're going to go on to another type. This is add list, where all three are vectors. This is a vector at A1, A2, A3. The offsets are always like this. It's A3 offset 0, offset 1, offset 2. They are all that way. There's no offset jumping. Alright, this is add list, so this 1 is added to the 10, get 11. The 0 to 20, you get 20. 2 to 1, you get 3. Alright, this also comes in the multiplication. So, we go to the next one. Here the same idea. This is at A1, this is at A2, this is at A3. But this time they're being multiplied. 1 times 10 is 10. 0 times 20 is 0. 2 times 1 is 2. There are no jumping offsets. For example, this is at A1 offset 0, A1 offset 1, A1 offset 2. Alright, now we're going to go to matrices. This is multiply this matrix times this matrix, and it gives this matrix. This matrix is at A1, this one's at A2, this one's at A3. So it's multiplying the one at A2 times the one at A3, giving the one at A1. Now, in order to tell the P code that these are matrices, you add 1,000 to the number of rows and put that in the control register N. Alright, well there are 3 rows. So this example, N, control register, was set to 1003. That tells it they're matrices and not vectors. Also, because these are matrices, having multiple rows, it needs to know what the offset jump is between rows. That value must be put into L. For example, if these rows followed each other, the offset in L would be 3, because of this would be at 0, 1, 2, 3, 4, 5, 6, 7, 8. But you could set L to 20, and that would mean that this is 0, this would be at offset 20, and this would be at offset 40. Now when you set your L, it has to be the same for all 3 matrices. They all must be offset rows the same value. It's only one value of L. So here we see a matrix that has values 5A, which means 1 decimal place, so that's 0.5, 0.5. These are 0.5, 0.5s. When this row here is multiplied by this column to make this first value here, the only hit on values is when it went 0.5 times 0.5, which is 0.25, which is what this is here, because a B means 2 decimal places, so that's 0.25. So this is the first example of multiplying a matrix times another matrix. Here comes another example. Here is an example where we're going to raise this matrix to a power. We're multiplying it by itself, And then we keep doing that over and over again. We square it and square it and square it 5 times until it reaches a steady state. Well, you know, with this much accuracy, raising it 5 times becomes 1/3. So 1/3 probability of being in this state, 1/3 in this state, and 1/3 in this state. That's a Markov chain. Well, you all know that. Alright, we go to the next one. Here it's multiplying this matrix times this matrix. Well, look at the ones in here. What that's going to do is it's just going to move the rows around. Here, the top row is 0.5, 0.5. It got moved to the bottom. The middle row, 0.5, 0.5, got moved to the top. And the bottom one, 0.5, 0.5, got moved to the middle. Well, that's the last example. And this is called Video 109. If you need more information, you should go to the Vids program, subprogram 1, tab 9 through tab 19. Well, this is the end of the video.